So on the back of the notes, starting with where it says, so sampling distributions again. Does yours start with the sampling distribution?
Yeah.
Okay. The sampling distribution of a statistic. So this is something that people get really, really confused with at the beginning. If I wanted to write out, if I were doing something like flipping a coin 3 times, I'll do it with flipping a coin twice. We can do heads or tails, and then off that, heads or tails, heads or tails. So our whole sample space would be heads, heads, variable heads, tails, tails, heads, tails, tails. And so if I were to graph, what if we were doing like percentage of tails? This would be 0, this would be 50%, this would be 50%, this would be 100%. So if I graph that, even though you can't really tell with my handwriting, the pen, but y'all can see what that is, right? So this is a sampling distribution of all of my possible options. So you could imagine that if I got to like, let's say I went to like 7 rows, that would be a lot to write out. My distribution is going to start to have a lot more dots on there, and we would see what it would look like. So y'all with me that if I wrote out the entire thing and made the dots, that is a sampling distribution. So if we're doing something like the example we just did about all passengers from that airport, would I want to figure out every single passenger who has ever been to that airport, which is a continuous thing, and put a dot for every 5 I got to see what percent of those actually went through random screening?
No.
Could we physically obtain that? Probably not. So the important part is understanding that a sampling distribution, and this is your blank, is all possible samples. So like, let's say we are dealing with the lottery. You get 69 numbers, and there's 1 through, this is only part of the lottery. I'll look this up to remember what number it was. For Powerball, 1 through 69 are what you can choose, and you get to choose 5 of them. So if I wrote out every single way that I could pick 5 numbers, which is over 112 million, I think, then that would be my sampling distribution for that. So I don't usually want to deal with all possible samples. So what we do instead is we approximate the sampling distribution. So in that second sentence, whatever it is, distribution obtained from a fixed number of trials is only an approximation. That's your fill in the blank approximation. So if I say, is this a sampling distribution? You need to say, no, this is an approximation because not all possible samples were used in most of the ones we did. So I'm going to make that connection more and more as we go, but I just need you to understand where we're at right now as far as only if I do every single possible one there possibly could be is the only way that actually is a sampling distribution. All right, so this side I'm kind of going to talk through pretty quick for right now. A statistic used to estimate a parameter is blank if the mean of the sampling distribution is equal to the population. So if I am sampling and our sample got a 3.0 GPA and our population was also 3.0 GPA, was that biased? So that first blank is unbiased. So if the statistic and parameter are the same, that means it's unbiased. If I just took your class and did it against the whole senior class, I would hope that would be a biased sample because your mean would not be what the entire senior class population average would be. So larger samples would more likely produce an estimate close to the true value. What happens there if I only did like a sample size of 5 and I got somebody who just did nothing and had a terrible GPA, that would really bring it down. But if I had a group of like 100 and I had somebody that had a really bad GPA, it wouldn't pull it down as much. So that's just why the fact that obviously larger samples are going to estimate a little bit closer to the true parameter, because if there is one that's kind of like an outlier idea, it has less pull towards that. Third paragraph, the variability of a statistic. I think that's blank for y'all. Is that one? Third paragraph. Variability of a statistic is described as the spread of its sampling distribution. So variability of a statistic, how much it varies. So larger samples are also going to give a smaller spread. If they're an outlier, they're going to contribute less, which is going to bring that spread in. Do y'all have blanks in the last paragraph? Okay, so we can think of the true value of the population parameter as the bullseye on a target, and the sample statistic as an arrow fixed at the target. Bias and variability describe what happens as we take many shots at the target. If our aim is off and we consistently miss the bullseye, do you think that that is describing bias or variability? If I am consistently missing the bullseye, bias. So that first blank is bias. Blank means that our shots are widely scattered on the target. Is that high variability or low variability? High variability. So ideally, properly chosen statistic from random sample of sufficient size, ideally what we want, do we want a high or a low bias? We want low bias, and we want high or low variability. Low variability. Are those blanks or are those written? That's the very, very last thing on the left side. Low bias and low variability. Alright, so let's visually draw this. So we've got a target. I'm not going to draw a very good target. If I want one that is high bias and high variability, is it going to be centered at the circle? So I'm going to center it somewhere else, and do I want it close together or spread out if it's high bias, high variability? So something like this would be high bias. And so you are just kind of drawing dots on there and writing what it is. I really can't go with that. All right, so let's say that we have one that looks like this. So I'm going to answer high or low bias and high or low variability. So what kind of bias is this one? Low. Because it's centered where it should be. If I called this one high variability, would that be high or low variability? So if I have one that looks like this, what's that one going to be? And this one I haven't done yet. So dots are all together, but they're not centered.